Welcome all, this is my new channel. Here I'll be discussing geospatial analysis and GIS concepts. The subjects and methods I'll discuss are ones that I've used in my previous employment. The aim of this new channel and these videos are to produce reference material and communicate with the GIS community. I'd like to generate conversation and preserve some of the knowledge I've obtained, as well as gaining feedback and understanding of what's required. I'd also like to gain perspective and understanding of additional ways of conducting work or work requirements in the GIS capacity. Okay, with that introduction covered off, I'll now get into the subject of this video. This video will be focused on the use of a search cursor. I'll demonstrate the use of a search cursor within a Python script. Much of the first videos I cover off will be Python script focus with the aims of developing a toolbox, a geospatial toolbox. Within the description of this video, I'll provide a link to the Esri help documentation. This is the official documentation about what a search cursor is and how to use it. As the summary states there, a search cursor will return rows of attribute values from a feature class or table. There's the syntax of how to use it. I'll go into that a bit in depth in an example later. The way I have used search cursor, I will use it to read each attribute of each feature within a feature class. So the search cursor is just a read function of the features in a feature class, peeling through either the geometry or the attributes. An update cursor will change the information within the attributes or geometry. And an insert cursor will add more features into a feature class. The example data I'll use for this example video come from the Australian Bureau of Statistics. So on the left of my screen now are a number of postcode boundaries. This is surrounding the Melbourne area. So as this pop-up states here, these are the postcode values or the codes. And on the right of the screen here is a CSV table of the Australian Bureau of Statistics census data of population. So I've combined both of these toolsets within a script I've built. So normally the postcode data will just have simple information of the postcode code, numerical value, and just really the shape length, default geometry. And what I've done with it in the script is match the postcode value with the row of the census data. Now, this can be done with a simple join. You're expected to have one entry of a postcode entry within the data and one shape, geometry shape for those two bits of information to match. Later I'll have examples of where you'll have multiple rows, and I really just feel that conducting a join or a late within the ArcGIS Pro won't perform as customizable as what a script can. Case in point, for example, really, the census data has these postcode values here, and they're prefixed with POA. Now, this can be fixed either within Excel or within a calculate values, so you could remove these values. But what if there are multiple case values of a prefixed code? I feel like with a language toolset or a customized toolbox, you can create more handling rule sets to deal with edge cases like these. So again, in the description below, linked for the websites where you can download this Australian Bureau of Statistics if you want to follow along. So these are the packs for the Excel spreadsheet data on the right there, and these are the boundaries here. So if you would like to, I've also downloaded either mesh blocks, and some statistical information can be provided in a multiple different administrative boundaries in which that you have to make those matches between the information and the geographical location of where that exists in location. Okay, now getting into the technical side of this video, going into the actual Python script of using a search cursor. So I've just changed the recording view, so I'm hoping that the text of the script will come across clearer. I'll aim to provide this early script example in the description so that you may copy it and interact with it as you like. So as this video is dedicated to the use of the search cursor, I won't be adding too much additional works to this. Within most of the scripts I write, I like to have a lot more information or handling for edge cases, but I'll strip that all back so this is a bit more clearer. In future videos, I'll incorporate more of my general construction of my scripts. This should minimize misunderstanding or cross paths with any technical terms or uses. I aim to cover off this pretty quickly, but I'll aim to go line by line and explain what I've done to set this up. One further bit of housekeeping, I'm not using any IDEs or integrated development editors. I'm just using the default IDLE that comes with Arc Pro. If you are using the same IDLE like I am, and you want it to look the same, you can come into Options, Configure, Fonts and Tabs, and your highlights to turn it into the black and the highlighted text there. Now going into line by line and describing what I've set up here. So imports arcpy, as the search cursor requires the import of the arcpy to function. Going into this block here is the variables, import data. So this is a local file that I'm using. You'll obviously want to change this to where you've saved your input data. As I said, from that example, I'm using these postcodes data that have the census data correctly associated to each of the land areas. This is an address to the file within the database. I've got double quotation marks on the end because I've got a single quotation within my folder. Next part of this is going into the field names. So these need to be the actual field names and not the alias. Just opening up the attribute table to do a bit of the data exploration, as you might need to do this before running any of the tools and the scripts. Seeing here we have the population, so the total population of people, and then the age groups broken down within the data there. Just the further exploration of the fields, we have the field name and the alias. Make sure that you are using the field name. I've been caught up a couple of times by aiming and writing within the code of what the alias is, and the field will not find, or will find the incorrect field there. So just remember that point there. Just making a variable here of what the field is called. Later I'll provide an example of selecting and indexing fields. So in the case that the order of the fields gets changed, or you've got a different supplier and a different organizational structure. This is pretty important when using cursors in general. So their variables are covered off now, where we can get into the search cursor. So as per the documentation, there's a number of different examples of how you can use these search cursors, but the way I'm using it is just my preferred method. So structuring this out, there aren't too many decisions and choices needed to be made here. This first requirement will be the data that you will be inputted into the search cursor, and then within this section here will be a list or a collection, a grouping of the fields that you'll be providing. And so I've specified those two fields and wrapped that in a list. Within the search cursor, the insert and the update cursor, you can leave this blank. All other arguments after the data are optional, but it's suggested not to leave that blank, as you'll be loading or interacting with all of the data. Particularly the case for update or insert cursor, you may not want to be changing or importing data into all of the fields. You want to be very controlled and selected on the data that you wish to interact with. One, for efficiency, and two, as the risk there is that you're changing data unintended to be changed. Cool, with that feature work covered off there, we then import it as a specific variable that you wish to describe. I've called my search cursor searchcur1. You can name this whatever you would like or what's logical for your use. In a number of my scripts, I've created a number of search or update cursors, and I need to know specifically what one I'm using on what feature class. This will allow me to call upon the information that I'm querying correctly and apply that into any of the algorithms or any of the calculations that I'm conducting. What we've done within this line, the busiest line of this script, is to create the search cursor. The next thing we'll want to be able to do is use it. So indented now, we're going to call that search cursor and iterate through it. So we're going to use a for loop. Again, this is a specified variable here. This part here can be whatever you would like to call this row or iteration of the search cursor. I'm calling it a shortened version of searchcur1. Again, like I was saying, I might have multiple iterations, nested iterations or loops within loops, and I might want to call the correct information that I want to be using. I'll just add this line here. If you just want to print the entire information for these fields for this feature within this iteration, you can just call the entire feature information. So that's an example there. We'll run this in a second and we'll see what the output is. This feature class contains 265 features, so it won't take a really long time to run. What I do when I'm crafting my tool sets or scripts, I will just collect a sample set, so just a small amount of the total data that I want to be using, and I'll just run and test the outputs and test that everything's logical and makes sense before I run it on the entire set. That way I would save a lot of time in that proving and testing of how the script will perform, and then proofing that it is actually conducting the work that I want it to. But as stated, if we call upon the entire feature class information, this will provide a list or depending on how it's set up, maybe a dictionary. But then in calling the specific information that we want, we'll have to give it a suffix of where it's located within how we've called the field information. So this should make sense after we run it. Anyway, but for this output, we're just printing information, we're just viewing it as a human. Later in other videos, I'll provide examples of data being changed within the feature classes. But for now, we just want the visual confirmation that this script is working. So again, just calling the postcode field, what is it? So within our print, we're giving a text string and then concatenating the string together. So plussing by the string, and we're bracketing this value, whatever it happens to be, as a string. In this event, if it's an integer type piece of information, then it'll flag an error and won't be able to be called within this print function here. And then plus another bit of string to say what the population is, and we're calling the next item in this list. So the numeric ordering of Python goes 0, 1, 2, 3, so we're going 0, which will be our postcode field, and then 1, which is the total population field. And then we're just adding a new line. There's more elegant ways to do this, but we're just printing a blank space. There's a separation between each of these features. Cool, and then that will conduct through the entire feature class. That's a loop that will go throughout the entire search cursor, which is the feature class. And then once this part has finished, we will then delete the search cursor. It's very important that search cursor, update cursor, insert cursor, whenever you're finished with the iteration, before you go into your next step, your next phase of the script, make sure you delete it. It will make this script perform much better, and also will avoid some critical failures. With that done, we can run the script. The search cursors are intended to run quite quickly, though I would have edited some of that out. As we can see with this result, when we print the first part, that's where this part of the script is working, and it's just printing the unformatted, just raw values of what's been provided there. The field that contains the postcode identifier code is in a string, so that's coming through as text, and then this field is either short or long integer. And then there we go, we've got my formatted version being that this postcode is this number, and the population is that there. Okay, so I've modified our script a bit just to incorporate another demonstration before we close off this video. I've added a dictionary with some data, and I've added an iteration through this dictionary. This is a predicted value of how much the population is likely to increase. So within this dictionary, you have the key of the element within the dictionary, of the information within the dictionary, and then both the postcode code and then the factor of how much growth is likely to be experienced. So that's contained within each of the elements within the dictionary. And this dictionary information just continues past the edge of the script here. In an employment environment, it's likely that this information might be covered in a report or a CSV, and this might have to be referenced. You usually wouldn't have it within the script. And so then we've just, within our search cursor, we've added another iteration. We've created an iteration through the dictionary. So for this section here, just like we created the for loop before, we will specify a variable that will call upon the row information of the dictionary. And this will be our dictionary stated as previously in the script over here. And the first thing I'll do within the for loop is I'll make sure that the postcodes, both within the dictionary and within the search cursor, are aligned, are correct, and so the correct information is associated with each other. In real-world practical settings of this type of script, I've done check cases if the dictionary information or whatever information you want to associate with your main target feature class is not available, as in a match has not occurred, then you want to flag at least a message, or this is the instance that the information was not able to be matched. And it may be worth doing some data handling to identify some edge cases and make sure that they are matching. Or if the information isn't matched, have a case that the data can still be collected in a geographic location, just outside of real-world data, if this needs to be represented into a brief or something. What am I doing within this if statement? So first of all, I'm making sure both of the variables have been converted to a string. As my entry of the dictionary, there's no quotations around this value, so it is considered a number. And before I forget, I'll remove this print statement. That was just for demonstration purposes. That was just displaying the row information. What I'm specifying here is similar to how I was specifying the information out of the search cursor, but here we will list the dictionary, we will list the variable of the iteration in square brackets here, and then the section of the square brackets will be the postcode. That's that information. So if it is equal to, equals is if this information, this value here is equal to what's on the other side of this, then we'll proceed through. And if not, it'll go on to the next iteration within the dictionary. So just taking a second to reframe is that this search cursor will iterate through the feature class. Into the feature class, we'll go to the first feature. We'll then process this information, print this, whatever's contained here will be conducted, and then we'll go and iterate through the dictionary. So while on the selected feature class, we'll then iterate through the dictionary and make sure that the feature class is matching the information within this dictionary, which is the postcode. So we've got postcode from feature class, postcode from dictionary, and then we'll progress through the rest of this section here. Make a point of saying that, as with many of my scripts, I'll have multiple nested iterations. These can be confusing, and at times effort should be made to make sure these are as most efficient as possible. Right, so I'm making another variable here, and I'm conducting a calculation. So I'm specifying within the dictionary, in the dictionary iteration, and element number 101. This is the factor of how much change will be affected to the population count. And so that population factor of growth times by the current censored population will be the next value that we want to call from. The next variable I want to establish is how much change has occurred between the last census and the predicted next growth. And what the returned information will be is a higher number if the population is expected to increase, or a lower number if the population is expected to decrease. And I've created the random data for both use cases there. And for this example, that's all of the pretty much coding that we need to do. Now we're just going to provide the results as a message. We're not really going to do anything with the data. As I said, I'll save that for the update cursor or insert cursor scripts later. For now, we're just going to provide a message. And so the next year's growth is expected to be, which our next population value here. And I've written this into a string formatting arrangement. I've also done this for the print that we provided earlier. And for our next population value, I've added 2 decimal places, as we've got 3 decimal places for the factor. The next segment of the string is the projected growth, so we can actually see the raw value. Nothing special really within this, it's just taking that information straight from the dictionary. And then how much change is being observed, as we've calculated earlier up here. And again, I've provided the formatting for the 1000 separators, but I've provided no decimal places. I've given no text formatting, it's literally for the growth factor, it'll just be the value as read here. Okay, testing the script, realizing that this new line is not in the right location, we'll just throw it after the iteration through the dictionary. Usually hard to tell, but this is on the line of the dictionary, so that will all complete. And then once this line and the continue here is run, it'll come back to this print, do the other iteration, and then go down to the delete of the search cursor there. All right, save off and run again. Okay, so now we'll have what the postcode is, what its current population as of the census. Next year's population is expected to be this number. Its growth from the dictionary is that. And what is the population change? And I think there are a couple here that have the negatives. So the population growth is expected to decrease. And that's the growth change. So you can take this and go further within its categorizations and alike. You could provide a simple summary category of how much change. Is there a very significant change in the positive? Is there a significant change in the negative? Is there only a slight change? We might explore this further in the update and the insert cursor. This will close out the video on search cursors. Remember that search cursors are a very efficient method of iterating through and reading a feature class. I hope you found this video very informative. If you have any questions, suggestions, I'm very interested to hear if you have any examples of this type of work, and I'd like to assist in any way I can. Anyway, take care and goodbye.